Hey, Mr. Richards here. Today's grade 7, Unit 4, Lesson 5, Anchor Problems. In question 1, at the problem store, M&Ms and Skittles are sold for 50 cents per ounce. Kavita puts some M&Ms in a bag and then adds 8 ounces of Skittles. The total cost for her bag of candy is $6.50. Kavita and Mary write the equation 5/10 times x plus 8 equals 6 and 50 hundredths to represent the situation, where x represents the number of ounces of M&Ms. Kavita says to solve this equation, you first must distribute the 5/10 through the parentheses to get 5/10 x plus 4 equals $6.50. Mary says that to solve this equation, you first must divide 5/10 on both sides to get x plus 8 equals 13. Do you agree with either Kavita or Mary, and why? Finish solving the problem to find out how many ounces. Okay. Well, let's start off by just writing that original equation down, which was 5/10 times x plus 8 equals the $6.50. Now, in Kavita's method, she's saying you have to distribute first. Fine, let's distribute. And sure enough, she correctly got 5/10 x plus 4 equals the 6.5. We're going to subtract 4 from both sides. 5/10 x equals $2.50, or 2.5. Divide by the 5/10 on both sides, and you get x equals 5. Okay, well, what about Mary? Mary's saying you to divide first. Well, if we go back to the original, we're going to divide by 5/10 first. And so we get x plus 8 equals that 13, and she solved that correctly. We're going to subtract 8 from both sides, and we get x equals 5. X equals 5. So I'm going to agree with both here. And so how many ounces? 5 ounces. So ultimately, it doesn't matter in this question whether you distribute or if you divide, you'll get the same solution. What about the next question? The taxi fare in Gotham City is $2.40 for the first half mile. In addition, additional mileage is charged at the rate of 20 cents for each additional 10th mile. You plan on giving the driver a $2 tip. How many miles can you ride for $10? Yikes. Well, let's look at what's given here. For this 20 cents for each additional 10th mile, that's kind of a complicated thing. We're looking at how many miles. Well, let me ask you this. If it's 20 cents for a 1/10 of a mile, if I multiply that by 10, that would be $2 for 1 mile. Again, if I multiply the 1/10 by 10, I get 1 mile. 20 cents times 10 is $2, so I'm at $2 per mile. Okay, $2.40 for the first half mile, $2 tip, $10. Okay, now we're kind of getting close to being able to solve one of these equations. We know it's going to be $2.40 for that first piece, that first half mile. We're going to give a $2 tip. And then beyond that, we know we can go $2 for each mile after that first half. And we know we have $10. So there's our equation. If we have $4.40 that we're already dedicated to giving, plus $2 per mile equals 10, we can subtract by $4.40 on both sides of this equation now. We're left with 2x equals $5.60. Divide by 2 on both sides here. And if you don't have a calculator, You could always long divide, right? We get $2.80. Or 2.8, not $2.80. Hello. 2 8/10 miles. But that's the additional stuff. We also have this first half mile that we can add back to it. And so we actually end up with 3 3/10 miles that you can ride with those $10. So the $2 for the tip, the $2.40 for the first half mile, you have $10, you can go with the additional 2 8/10 miles. You add the original half mile back to that, and you get 3 3/10 miles. Let's move on to question 3, our last question. The ages of 3 cousins are consecutive integers. Now, consecutive integers are things like 1, 2, 3, or 10, 11, 12. Those are consecutive integers. Calculate their ages. I'm not going to worry about the tape diagram right now. I can. Basically, the way a tape diagram works is you've got this rectangle that we're going to call the tape, and we're going to divide this into the 3 kids. If the youngest cousin is X, the next one is the age of the youngest plus 1. The next one is the age of the youngest plus not 1, but 2. I mean, you look at this, if this was X, plus 1 was 2, plus 2 is 3. If this was X, plus 1 is 11, plus 2 is 12. So that will help us set up our equation because we know the sum of these ages is going to be 45. And so X plus X plus 1 plus, is that a plus? It should be a plus. That should be an X plus 2 equals 45. So X plus 1 plus X plus 2 equals 45. And now if we can combine some of these like terms, we have an X, an X, and an X. X plus X is 3X. Then I have a 1 plus a 2 is a 3. And that's all going to equal 45. So when they're all on that same side of the equation over here, I can combine the X, X, and X to be 3X, the 1 and the 2 to be 3. They're going to equal 45. When I subtract 3 on both sides here, we get 3X equals 42. And when I divide by 3 on both sides of the equation here, 42 divided by 3 is going to be 14. Well, the youngest cousin is 14 years old. Then we have 15 and we have 16. They're 14, 15, and 16 years old. And of course, those 3 numbers do add up to be 45. So that's it. That is it for this lesson. For the anchor problems here on problems 1, 2, and 3, 7th grade, Unit 4, Lesson 9. Good luck.